Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, or the Networking 2 course at AACC, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 6.3.3.6, where we're going to be taking a look at Inter-VLAN routing, and specifically, we're going to be working on providing Inter-VLAN routing through router on a stick. So let's go ahead and dive in and take a look at the topology that we're going to be working with. As you can see, it's very straightforward and it's a very simple topology, and the reason for this is we want to keep things simple to take an inductive approach so that we can start small and then work into larger scenarios. Now, this is definitely one of the topics, Inter-VLAN routing, and specifically the router on a stick method of providing Inter-VLAN routing that can cause some confusion. So what I want to do real briefly is go to the blackboard here and let's talk about some of the different ways that we can do Inter-VLAN routing. So we saw that you can use a multi-layer switch. I'll just put MLS for multi-layer switch, and I can have a host here in VLAN 10 and a host here in VLAN 20, and let's put another host here in VLAN 30. Now, on the switch, I typically configure switch virtual interfaces, right? And we've seen how to do that, where we go into interface VLAN 10 or interface VLAN 20, and we put an IP address. And that SVI serves as our default gateway. And all of the routing functionality, everything that's required, is taken care of on the switch. And this is a very cost-effective use case when you don't want to have a router in your configuration. Because if you had a service provider, right, let's say that this is your internet service provider, you can even connect them in as long as it's a connection that the switch will support. You can even connect in your ISP and you're good to go. Now, obviously, there are some things lacking here. Where's the firewall? How am I going to provide intrusion detection? So again, there's obviously some questions that this topology raises. However, this is a possibility, and we enable IP routing on the switch from global config mode. TING, sorry about that, IP routing. And we have multi-layer routing, or multi-layer switching. And so if we wanted to provide some sort of access control, the ACLs would be placed on the SVIs in order to provide that access control. So let's go ahead and let's square that off. So this is the first method that will allow inter-VLAN routing, because remember, if all we have on this switch is no IP routing and VLANs, right? If it's just we're using it as a layer 2 switch, VLAN 10 cannot talk to anything on VLAN 20 by default. 20 can't talk to 30, and 30 can't talk to 10. So no one can talk to anybody else because we've provided VLAN separation. It's not until we enable the IP routing on the multi-layer switch that we get that inter-VLAN routing. So now let's talk about a second approach, and this is probably the least cost-effective, but in most cases it's easier to envision how this would work. So let's say that we have simply a layer 2 switch, and it could be a multi-layer switch, but we're just not doing IP routing, but I'll say it's a layer 2 switch. And over here I've got a host in VLAN 10, here I have a host in VLAN 20, and then here I have a host in VLAN 30. Now, when we take a look at this, and let me draw our internet service provider up here, right? The internet, we're trying to get out to the internet. How would we do this? Well, with a layer 2 switch, as we've seen, VLAN separation ensures that VLAN 10 cannot talk to 20, 20 can't talk to 30, and 30 can't talk to 10. So no one can talk to anybody else in this default layer 2 configuration. So when we decide we want to provide inter-VLAN routing. In other words, allow communication between the hosts in the different VLANs, we can use a router. And typically that's the option that most people look at and say, well, that makes a lot of sense. Now, here's how we can do this. And let's say there's our serial connection out to the internet service provider. So when we look at this, here's one way that we could do this. And this, again, is the least cost-effective way to handle this, is I can take an interface from the router and put it into VLAN 10 and say that this is going to be, we'll say it's 192.168.x.1 for the default gateway, and the X being the VLAN. And then I'm going to take another interface and we're going to put that in a port on the layer 2 switch. And that port would be in VLAN 20, and then it would be 192.168. Sorry, I wanted a 1 right there. 20.1. And then we take another port on the router and we plug it into the switch, and in the switch it goes into VLAN 30. And so you can kind of see how this is working. And then here it's 192.168.30.1. So the router has a 1-for-1 ratio to ports to VLANs. So for every VLAN that gets created, the router is going to have a port. And this is a way that you can provide inter-VLAN routing. Now, when we look at this, it should make sense to you immediately that this is obviously the least cost-effective way to do things, because I'm chewing up valuable router ports. Again, on the 2911, on the ISR G2 2911, it only comes with 3 gigabit interfaces by default, gig 00, 01, and 02. And so if you had 3 VLANs that you were working with, saying that, this is HR, maybe this is management, and this could be engineering, right? You are out of interfaces on that router. Now you need to look at purchasing expansion cards. And you're using up valuable ports on the front of the switch, right? These are data ports on your switch, and now for every VLAN, you're going to have to allocate at least 1 port so that the router can plug in. And all of these interfaces on the router, these are all your default gateways for the hosts that sit here. So when you either do DHCP, which you could do on the router, or you give this guy the address 192.168.10.10, when you set the default gateway, you just set it to 192.168.10.1. So this is another way to do inter-VLAN routing. And again, this is by far the least cost-effective approach. And so we'll say this is approach number 2 to inter-VLAN routing. So now let's take a look, and we'll use sky blue here, at the third approach, which is router on a stick. And this is by far probably the second most cost-effective method. The multi-layer switch is probably the cheapest way to do it because, again, you don't have to buy a router. However, this gives us some functionality that the multi-layer switching does not. With the switch, if it's a serial connection, right, out to the internet service provider, switch is not going to work, right? The switches don't support serial connections natively. They don't support serial connections natively. So here's my ISP. Let's take a look at router on a stick. So we'll say here's my ISP, and there's my serial connection, and here is the router, the on-premise router. I only need a layer 2 switch here. It can be a pure layer 2 switch like a 2960, right? And I have a single connection into that layer 2 switch. However, I can have hosts in VLAN 10, I can have hosts in VLAN 20, I can have hosts in VLAN 30, and I can have hosts over here in VLAN 40. Right? So I'm going to add an extra VLAN in. It's not that you're limited to 3, right? But again, from a scalability perspective, you have to weigh what is your use case going to be? How many VLANs are you going to have is probably going to be driving what decision you make here out of these 3 different choices. Now, here's how the router on a stick works, is that, remember, what kind of a port allows me to send multiple VLANs over that port? Exactly, a trunk port. So here on the switch, we still have VLAN separation, right? That 10 can't talk to 20, can't talk to 30. Nobody can talk to anybody else because they're segregated off by VLANs. Now, when we want inter-VLAN routing, we can configure a single interface as opposed to 3, right? As opposed to having to dedicate an interface to a router port and using additional router ports, we have a single router port and a single switch port that will service all of the VLANs on this switch. So we configure this port as a trunk port, and that port right there on the router, we configure what are called sub interfaces, right? So you've got your main interface like a gig 00, but what we can do is we can say we're going to have a gig 00.10. Now, when I configure the sub interface, what I'm saying is that there has to be some sort of marker, some sort of identification that comes up across the trunk port that identifies and differentiates traffic that should use this sub interface as opposed to a sub interface like Gigabit Ethernet 00.40. In other words, how does the gig 00 interface on the router separate out whose traffic is for who based off of VLAN? And this is where we come full circle all the way back to the very first activity we did, 6217, when we mentioned the Dot1q, the Dot1q tag, right? So in other words, 802.1q. And this is what we're in. Sorry, look, I moved over there. And we'll leave it with 802.1q. We're talking about the 802.1q, the VLAN tag. And it's the VLAN tag that comes across the trunk port. Remembering the trunk port allows all VLANs to come across it by default. And when that traffic shows up here on the main physical interface, it processes that traffic, looks at the VLAN tag, and then the virtual sub interface processes the traffic based on the VLAN tag. So hosts in VLAN 10 would then go to gig 00.10. Hosts in VLAN 40 would be processed by gig 00.40. But backing those virtual interfaces is the router, and the router will allow the routing to go between these sub interfaces, right? They're subs, they're below the gig 00, right? They're virtuals behind the gig 00. And so that's what's being allowed to happen here. And it's all about the 802.1q trunking, right? Or the trunk encapsulation that makes this a possibility. And you'll see when we go to enter the commands in, I'm going to force it. When you try to put the IP address on the sub interface, you'll get an error immediately that'll tell you, you can't put an IP here until you tell me how this sub interface is going to be differentiating the traffic showing up on the physical interface. Now, this is a great way to approach things. However, there are some limitations here. And again, it comes down to use case. So we're saying these are gig ports. Well, what if this layer 2 switch, what if this is a 48 port layer 2 switch and all the ports are gigabit Ethernet? We're oversubscribed here. 48 to 1 is our oversubscription rate. Now, in most environments, right, if these are just desktops and it's users doing normal work, that may not be a big deal. In a server environment, right, or if these are web servers, this could be a huge bottleneck right here, and that's the limitation. This is what we need to make sure that we're aware of from a design perspective, is that here, right, over in our individual port per VLAN, that's really not a concern, right? Because even if we had 48 ports over here, we're dedicating a gig of bandwidth per VLAN. And so that works out great. And over here, right, it's even better because everything's being handled internally. But that's something that we need to be aware of and cognizant of, is what is our use case? What is our network going to look like? What are we doing? And that's going to drive which of these 3 inter-VLAN routing scenarios we decide to implement. And again, we're about router on a stick, and that's what this is all about. But I wanted to cover this because this is where a lot of learners transitioning from simply segregating networks by VLANs, right? Subnets, segregating the subnets by VLANs. When the conversation of inter-VLAN routing comes up, it can become very, very confusing very, very fast, especially the router on a stick and the multi-layer switching. So let's go ahead. I'm going to leave that up and we'll transition out and we'll probably come back to that. But let's dive in here to this activity. So we're going to test connectivity without inter-VLAN routing. We're going to add some VLANs to the switch. We're going to configure sub-interfaces on the router, and then we're going to test connectivity. And we've got all of our addressing table information up here. We're going to be dealing with 172.17s, 10 and 30. All right. So let's ping between PC1 and PC3. So let's pull up PC1, and we'll pull up, excuse me, pull up PC3 here in a second. So let me go ahead and say, ping 172.17.30.10. So can I ping from PC1 over to PC3? And we get our request timed out. And while that's running, let's pull PC3 up. And we'll kick off a ping over to 172.17.10.10. And so what do we see here? We see that none of the pings are going to work. Now, this makes sense, right? This is what should happen. In fact, let me make sure that they say that this is exactly what should happen. Yeah, so the switch is already converged because, yeah, so the 2 PCs are on separate networks, right? So even if they're on the same VLAN, which, let's take a look at the switch and see. Let's take a look at the switch and see here. And let's go into privilege exec and say show VLAN brief. Right, and this is what I was hoping to see here. I apologize, the mouse is not cooperating. So even if they're in the same VLAN, they're not in the same subnet. They're not in the same broadcast domain. So, and we did this in an earlier activity where it had us ping, and even though everything was in VLAN 1, you could ping things. We had different subnets, right? We had different VLANs configured, or I'm sorry, we had different subnets configured. So we had, 172.17.10, 30, and 20. And as long as they were in the same subnet, the same broadcast domain, they could ping each other, even though they were all sitting in VLAN 1. And that may have made you pause and say, well, wait a second, how is that possible? Well, remember, they're all in the same VLAN, and that may have caused a little confusion, but more importantly, they're in the same subnet, they're in the same broadcast domain, so they can communicate with each other. Here, it's different. Here, we don't have VLAN 10 over here on the right-hand side, and it's not in the same subnet, in the same broadcast domain as VLAN 10. So what we have is 2 hosts in the same VLAN who are not in the same broadcast domain, who are not in the same subnet. And that goes back to that point I was driving home. A VLAN is a subnet, is a broadcast domain. That's how you have to think about it. Now, that's why they can't communicate with each other, because yes, they're in the same VLAN, but that is irrelevant when they're not in the same broadcast domain and they're not in the same subnet. Because when I'm on host PC1 and I say ping 172.17.30.10, what does PC1 do? It looks into its network table and says, I don't have a network for that. And then what is it going to do? It's going to send that traffic to its default gateway. And so this is where we need a default gateway to do the inter-VLAN routing. And if that default gateway doesn't exist, let me put that back up here. If that default gateway doesn't exist, and let's pull PC1 up here and go back to our desktop. Yeah, and it does exist. So the traffic is being sent to 172.17.10.1. Well, can we even get to 172.17.10.1? Absolutely not, because that's going to be the IP address on the subinterface on the router. And so this is why we have no connectivity. All right, so let's go ahead and take a look, and there's no need to fast forward here because again, the activity had been opened up, and so we're good, the pings don't work. So now we're gonna switch to simulation mode to monitor the pings, and actually, I'm sorry, we just did that, so no need to switch there. All right, so we're gonna add VLANs to the switch. Remember, everything is in VLAN 1 right now, and that is not going to work for us. So here's what we're going to do. Let me pull this back just a skosh. There we go. So we're gonna add VLANs to switch 1. So how do we do that? Well, we go from privilege exec with the configure terminal command, we transition into global config. Now, okay, create VLAN 10 and VLAN. I was looking to see if they want names on here. So we're simply going to say VLAN 10. Now remember, I'm creating VLANs. I'm not creating switch virtual interfaces. SVIs. That's not what we're doing. I'm creating the layer 2 VLAN. And there shouldn't be an issue if I was to say name, and I'll just say PC1. Right? And then we'll say VLAN 30, and I'll say name PC3. Okay, so we've created the two VLANs, and we're going to assign the VLANs to ports, right? So now I'm going to basically apply the VLAN to the correct port so that the host on the switch will know, hey, I'm in this VLAN. So that way when that traffic flows out over this trunk link right here and arrives at the physical interface, it will be able to differentiate the VLAN 10 traffic from the VLAN 30 traffic. So let's go ahead and let's do that. So we're going to get an interface fast Ethernet 011, and let me say do show run real quick here. I want to see what we have. Yeah, so you see there's no configuration on fast Ethernet 011, and there's no configuration on fast Ethernet 06. So we'll do the left-hand side first. So I'm going to say switch port mode access. We're going to say switch port access VLAN, and this is us applying the VLAN 10 to that port. So now it's no longer in VLAN 1, it's in VLAN 10. I'm also going to do spanning tree. I'm going to put port fast on here to make sure that we don't have to wait in case for whatever reason there's something further on where the port goes down and comes back up. And I'm going to say no shut. Even though it looks like it's up, I always say no shut just to make sure, out of habit. Okay, so there is that interface. Let's go into fast Ethernet 06 where we're going to say switch port mode access. So we hard code it as an access port, turning off the dynamic trunking protocol. We then say switch port access VLAN 30. And then I'm going to say spanning tree port fast. All right. So now we're set up on those ports. And so let's do a do show VLAN brief. And we should see that VLAN 10, which is for PC1, is fast Ethernet 011 is in that VLAN, and fast Ethernet 06 is in VLAN 30. And so we've achieved what we were trying to get done here. So we're going to test connectivity again, and again, these are going to be unsuccessful because now they are truly in different VLANs, and I did not want to ping the default gateway. They're truly in different VLANs here, so it's not going to work. And it's not going to work over on PC3 either, right? Because again, now not only are they in different subnets now, not only are they in different broadcast domains now, but they're in different VLANs now. So in order to provide inter-VLAN communication, where I want to allow the hosts on VLAN 10 to talk to the hosts on VLAN 30 and vice versa, we have to configure some sort of inter-VLAN scenario where it's either a multi-layer switch, or we have a router with a physical interface in each VLAN, or we have router on a stick. And so this activity is about router on a stick. And so let's take a look here. And there are some nuances here and definitely something to keep an eye out. And this is a Cisco go-to on questions that deal with router on a stick. And I'll talk about it, about the numbering you use on your sub interface. And I harp on this quite a bit because, again, this is one of those sneaky little things that they'll try to get you on. So create the sub interface gigabit Ethernet 00.10. So let's pull the router up here. Let's give ourselves a little more space with which to, with which to work, and that for some reason just does not, yeah, that'll probably be good enough right there. Bring it over here and see if we can just go sideways. There we go, a little more success. So we're in user exec. The enable command is going to put me in privilege exec, and let's say show IP interface brief. Right, so we take a look, and this router has two interfaces, gig00 and gig01. So we're going to be using gig00. You can see it's labeled on the diagram above. Let me get into global config, and I'm going to go into interface gigabit Ethernet 0. Now they want us to create the subinterface, so I could say no shut and you got to bring the physical interface has to come up, right? So I could say interface gig00 no shut. Right? And the interface is going to come up. Or I could do all of my configuration and then bring the interface up. But you have to bring the parent physical interface up, right? Or else all of your sub interfaces will be down. All right, so now we can go into interface gig00.10. Now, a quick word on this .10. I could just as easily say .99. for VLAN 10, or .30 for VLAN 10, or .64 for VLAN 10. The number on the sub interface does not have to match the VLAN number. And this can cause tons of confusion. And this was that little sneaky thing I was talking about. Because make sure you pay attention when you're looking at router on a stick scenarios and you see interface gigabit 00.88 and they're using it for VLAN 5. And there's a sure way to tell what VLAN that subinterface correlates to when we look at the running config, because we have to define the encapsulation, which we will here in a second. But keep your eyes peeled for this, as this is a go-to in terms of trying to catch you not paying attention to the question or the details of the question. And I'm not talking about just exams. I'm talking about in general, right? Questions that we see in the book, questions that we see on our quizzes. So again, keep your eyes peeled for things like this, that the sub-interface number here does not have to match the VLAN. And this causes confusion for this reason. Once I get here, I have to set the encapsulation, right? The 802.1q encapsulation needs to be set. And so how do we do that? Well, the sub interface, it's encap.1q, and here's where the number does have to match the VLAN number we're talking about. So this has to be 10 if we're doing it for VLAN 10. It would have to be 88 if we're doing it for VLAN 88. It would have to be 30 if we're doing it for VLAN 30. Remember, that's different than the sub-interface number that does not have to match. That can be anything we want it to be. We don't have that same luxury here with the encapsulation under the sub-interface. And you can see where this is going to cause issues, because the student or the learner looks at this and says, oh, this must be for VLAN 10. And they don't look at the running config and see that. They look at the show IP interface brief and say, oh, yeah, I have a sub-interface for VLAN 10 because it says gig00.10. Not so fast. You have to look at the configuration on the port, because this is what dictates and mandates the VLAN that this sub-interface is servicing. All right, so before I do that, let me go back to this. Let me say, okay, VLAN 10 IP address and 172.17.10.1. I'll put my subnet mask on here, /24, and I'm going to hit enter, and we're going to get an error. So again, this is the error I was talking about that I'm going to walk you into, and this is a habit you got to break yourself of. In the first 5 to 10 times, you'll be like, oh yeah, that's right. I've got to put the IP address on here first before I entertain, I want to put the interface on here first, but you don't realize you have to do the encapsulation statement first. And this is where it comes back and it tells you configuring IP routing on a LAN sub interface is only allowed If that subinterface is already configured as part of an 802.110, which we're not interested in, IEEE 802.1q, which that's us, or ISL. And again, Inter-Switch Link is a deprecated legacy Cisco proprietary trunking encapsulation that you're not going to deal with. You're not going to see it. In fact, I think it's out of the Networking Academy curriculum altogether, which was a nice update. So we have to set the encapsulation first. We have to tell it that we have to tell the physical interface that when traffic shows up and it has a VLAN tag of VLAN 10, that it is this sub interface that's to deal and process that traffic. Now I can come back and put my IP address on here. And I don't have to say no shut because the parent interface was already brought up. So now when I say do show IP interface brief, you can see that if that is the output that you're given, and this goes back to that confusion I mentioned, if you get this output right here, and they say hosts on VLAN 10 need to or on VLAN 10 need to communicate with VLAN whatever, you may look at this and say, oh, well, I've got the sub interface here, so this is working for VLAN 10. It should work. Not so fast. We've got to do a do show run, and you could even trim it down to just the interface, but Packet Tracer doesn't support that. You've got to come down here and look at this. What is the encapsulation? Because that right there does not have to match VLAN 10. If this is for VLAN 10, the encapsulation must match. That number right there has to match the VLAN that this sub interface is servicing. All right, so we've taken care of that, and let's go ahead and do, and I'm wondering, okay, they want us to do, did they want us to do both sub interfaces? Okay, yeah, they want us to do both. All right, I just want to make sure they want us to do both. All right, so now we're going to go into interface gigabit Ethernet 00.30. We're going to go ahead and say encap Dot1q. What VLAN are we servicing? VLAN 30. And then we can throw our IP address on here, 172.17.30.1. with our /24, 255.255.255.0 subnet address. And that is it. There's no native VLAN here. So, okay, so both sub interfaces do show IP interface brief, should be active, and they are. All right, so the sub interfaces are active, so this should work, right? And you can tell by the intonation in my voice that probably not yet. There's one more thing we're going to need to do. So can PC1 ping PC3? And let me confirm those IPs. Yeah, 172.17.30.10. Okay, we're good. So no, it can't ping PC3 yet. And what about PC3 over here? Can it ping PC1? And the answer is going to be no, because if we can't ping one way, there's a very good possibility that we're not going to be able to ping the other way. So the pings don't work. Well, what's the problem? Well, if we read down here, it says step 2 of part 4, enable trunking. So on switch 1, issue the show VLAN command. What VLAN is gigabit Ethernet 01 assigned to? So when I come down here, I say do show VLAN brief, and we can see that gig 01 is assigned to VLAN 1. And so this is a huge problem, right? Because if that is in VLAN 1 and, right, and let's look at this. What kind of a port do you think that is? Do you think it's a trunk port right now? Or do you think that with dynamic auto, and again, we didn't say up here that that's a trunk port. This is just a router port, right? We didn't say it's a trunk port. And so this is the reason you have to manually hard code the switch side as a trunk port. So let's say do show interface gigabit Ethernet 01? Sorry, 01 switch port. What do you think happened here? Yeah, it's set to dynamic auto mode. So it sat there and waited for things to time out, saying, hey, whoever's on the other side, I really want to be a trunk port, but I'm not going to do it unless you tell me we have to do it. And so then the switch just sat there, and the router's not going to say, hey, let's be trunk ports, because the router, it's not a trunk port, right? We've just got sub interfaces on there. We've never said switch port interface trunk. And on the router side, we're not going to do that. So you can see it's enabled, it's dynamic auto, and then it falls back when it can't negotiate as an 802.1q trunk, it falls back to static access mode. And so it's an access port. And if it's an access port with VLAN 1, where's it at here? The access mode VLAN is VLAN 1. Which VLANs are going to be able to communicate over that link on the switch? Only things that are in VLAN 1. And so that's why it's not working. So let's configure Gig01 as a trunk, because we need to enable that port, interface gigabit Ethernet 01. We need to be able to enable that port to allow the transiting, right, or the passing of multiple VLANs, specifically in our case, VLAN 10 and VLAN 30. And we could also say do show interface trunk. And again, this one is critical. Remember that. Keep that in your CCNA bag of tricks. So we go ahead and we say switch port, mode, trunk. And again, I could say SWMT. And you can see it goes down and then comes back up. I'm going to say switch port, no negotiate, because there's no reason for it to be negotiating as a trunk because I've just hard-coded it as a trunk, right? And I could put a native VLAN on here, but it doesn't make sense because I never did an interface up here that would accommodate the native VLAN. And so we're going to leave, and let's see, do they want a native VLAN on here? On switch 1, show VLAN. I'm just double checking here. It's a trunk enabled, trunking on the interface. Now, this is a great command because back in the day, when you said do show VLAN, you might get quizzed on, they'll show you this output right here and they'll say, what kind of a port is gigabit Ethernet 01? Or they may say, why does gigabit Ethernet 01 not show up in this output? Where did it go? Why is it not showing the VLAN which is applied to that port, right? Or which VLAN the port is a member of? Why is it no longer here? And when we logically think about it, it makes more sense. Yeah, it's a trunk port, right? It doesn't belong to a single VLAN. It belongs to all VLANs. And that is why it doesn't show up here. And again, that's another little sneaky thing to keep in mind, is that if you don't see the port in the show VLAN brief output, there's a very good possibility that that is a trunk port, right? In fact, I know of no other way, and there may be other ways, I know of no other use case where you would want to do something where you pull the port out and it's not a trunk port. You get it to not show up and it's not a trunk port. But again, that's why we say Gig02 but not Gig01. Now, show interface trunk, let's run that as well. So do show interface trunk. And this last section, this is the important section. Which VLANs are in the spanning tree forwarding state and not pruned? And you can see trunking mode is on. We hard-coded it. The encapsulation is 802.1q, which matches what's on our sub-interfaces. And the native VLAN is VLAN 1. And that's okay, right? Because we don't have a native VLAN sub-interface up here on the router, right? And you can do that. You can do that. We're just not doing it in this activity. Now we're going to do a ping, and the ping is going to work. And it looks like we're missing something there, and maybe it can't be the ping. So let's ping over here. And now the ping should work because the packet, right, the PC1 says ping 172.17.30.10. It says, hey, I don't have an entry for that local network, so to my default gateway you go. And what does it do? It sends it right up here to the physical interface who says, I see an 802.1q VLAN tag. This will be processed by gigabit Ethernet 00.10. And it processes on the subinterface, and the subinterface looks at the destination IP address. And remember, we're on a router now. And it says, do I have an entry in my routing table for the 172.30.10? And let's bring router 1 back up. Let's look at that, right? Do show IP route. So do I have a network in my routing table that tells me how to get to the 172.17.30.0/24, or the network on which 30.10 would reside? And lo and behold, I have a directly connected route entry in my routing table that tells me what? Yeah, that tells me that if I get traffic destined for the 172.30/24, I'm sending it out gig 00.30, our sub interface. So then that traffic is going to get tagged with VLAN 30 and sent down the trunk link. It's going to show up on the switch, and the switch is going to say, let me investigate, right? Let me investigate and see if I have a MAC address entry for the IP 172.17.30.0. And so it'll look in the MAC address table. It might even have to ARP out if it doesn't. And in VLAN 30, it will have the entry for that host. And that is how the traffic is going to make its way from PC1 to PC3. So let's clear the screen here. And let's, for completeness, make sure that we can show that we can ping both ways, right? So that is how you configure inter-VLAN routing with router on a stick. Now, I'm curious here as to where these 10 points are at, and it's probably that I did not do something I should have done. Oh, the VLAN name. You got to be kidding me. Okay, I didn't see where it said the VLAN name, and I should probably wear my glasses when I do these activities. What was the name? And is it up here somewhere? It is not up there. And maybe that's just they want the name of what it's going to be. So let's do this. We'll say VLAN 10 name, and I'll do all caps, VLAN 10. Is that what they're looking for? Let's see if that's what they're looking for. And maybe if they're not looking for that, they're looking for the default. No name VLAN 10. Is that what they're, yeah, that's, so they don't want any name on there. My apologies. So they don't want any name on here. So then we'll say VLAN 30, and we'll say no name, and I think I said PC3. And that should push us to, yeah, there we go. So we're at the 60 out of 60. All right, again, one of the more difficult topics for learners who are new to the routing and switching world to grasp, and hopefully I'm confident that if you listen to this and you follow along, that you're going to have a much better understanding of exactly what router on a stick is, how it works, and how it can provide you with inter-VLAN connectivity. All right, well, this is going to wrap up Packet Tracer Activity 6.3.3.6, where we went ahead and did router on a stick between two VLANs. And again, you're not limited to two. I could have 50 VLANs, and I just keep creating sub-interfaces. All right, guys, thanks for watching. Have a great weekend, and I'll talk with you soon.